Is it audible? Is there anyone in the online mode? Okay. Thank you. Okay. So the thing is that we are discussing the Verilog HTML language, which is the first step when we are going towards the RTM to DDS. Okay, the RTM or you can say the behavioral coding can be described by using the Verilog HTML language. Okay, so we are just get the basic idea that how can you make it. It is the very simple language, and here we can describe something like say suppose we are discussing that. So in the last slides, we are just saying that the Verilog can compute the operation in parallel. Okay, and the Verilog also have the capability to define the z value if both have the different value. If A is different, B is different. So which one is having the higher driving capability? It defines the value of z, isn't it? Okay. So isn't it? Okay. Okay, so now let us discuss about this Verilog language, how it is discovered. So basically, there are the two languages for hardware description languages. One is the Verilog, one is the VHDL, isn't it? So basically, the Verilog language is defined by the verification logic, isn't it? And then it is the basically simulation. That's why it is just you can say that. It is more better as compared to VHDL. Okay, you just see that they have the system value of right now, okay, which is the language using for as a verification purpose. Isn't it? We are using the system Verilog for system verification. Okay, so it is standardized by the IEEE in 1995 2001 as well as in industry that in 2009 system Verilog has been standardized by the IEEE. Okay, so this is the some you can say basic VHDL, basic VHSIC. Basically, VHDL is the full form is VHSIC, very high speed integrated circuit language, circuit hardware description language, isn't it? So this is the full form of the VHDL. Isn't it? So now we go to the some basically the Verilog language that you will definitely be read in your you can say when you will be in the seventh semester or you can say when means in the graduation courses. Okay. So I will just discuss something in this so tokens. So suppose tokens means defining word, characters, numbers, anything. So we can create the white space, we can make the white space, we can make the comments. Suppose single line comment as the C language you can see. You can say multiple line comments by using this symbol. Okay, you can make the star, you can make the symbol, and you can make the multiple line of comments. Okay. You need to define the identifiers, number, string. So basically, you can define the numbers, string, all these things which is possible in C. It is more similar to C. If you know any language, then you can easily understand. It is not difficult to understand, isn't it? So, but it also has some capability to work on the you can say hardware, isn't it? So white space can obtain. Okay. So you can say tab, new lines, all these things are possible in this Verilog language. There are some reserved word in the Verilog language. Each language has some reserved word. Say here we define the module. Okay. We want to define this some functionality, then we define the inside that module. Okay. We will define the input, we will define the output. So these are the reserved words that you cannot use to define the any variables or any number. because these are some well-defined words in the well-known language. Okay, it is the case-sensitive language. We remember that it is the case-sensitive language. Okay, and so begins and always and modules or the keyword, reserve keyword that we can use in this Verilog HDL language, isn't it? Now we can see how many operators are there. So you can say all these operators already this is you can say plus, minus, invert, or you can say AND gate, and so all these equivalent. So all these keyword if it is not equal to, so all these keyword are well defined in this. You can say what is called that. Uh, um, you can say in the Verilog language, isn't it? Okay. So now identifier. Identifier is some unique name which you are giving for the module, isn't it? Okay. Object can be module, ports, nets, register, function, etc. So all these things you can say we can define. Okay, rules for identifier, define this module. Okay, so suppose you need to define the one name of this module. You cannot, like module is the predefined word in the language. Suppose you want the functionality of the AND gate, then after that you need to keep one name, module A1 and one, or whatever the want Y1, whatever the one name you want to keep, you can keep, but you need to keep. So what is the rule to keep for identifier? It will be, you can say alphabetic number underscore upper, you can say alphabetic character underscore, or you can say we can define by using this a small or a capital. Also subsequent character can be, you can say use it here in this way. So this is the simple my module register 1 2 3. Okay. So here you can define it, isn't it? Now it is the case sensitive. So we remember that we are defining this net and here we are defining the net. So both are different. Okay, the maximum allowed length is by default is 1024. Okay, but it may be longer, but generally keep below 1024. Okay. Expected escape identifier. Suppose I am defining the one block. Okay, suppose I want to perform the addition. Now suppose I don't want to perform that addition. Okay, then by using this escape, this you can say backslash. Okay, you can avoid that functionality, isn't it? So by using this simply you means you are escaping that functionality in the whole language. Say if I am defining some task, you can eliminate that task, isn't it? So this is the you can say identifier, and here you can avoid that identifier. Okay, escape identifier. You can avoid it. Okay, if you have any doubt, you may ask in the same time. No issue. Okay. Okay. So suppose I am defining the number. Okay. Because in the Verilog language tomorrow, maybe today also itself, you can see that we will go to the some simulation part. So you should know that what is happening here. There is the module and the module. Some family, you should have some familiarity what is happening here. Okay. So I just say that here we want to define the Verilog 1. I just want to say this is the 1. So by default, the Verilog language will consider as a 32-bit number and LSB will be considered as a 1 number. Okay. Suppose you want to define, um, okay. So you can say we can define the number real as well as the integer. Both number we can define. Okay, and can be say specified in decimal, hexadecimal, octal, or binary number, isn't it? So here you can just see that we can specify decimal number. So suppose I want to define the binary number, one bit binary number. How can I say? Just writing the coding in this way. This is the one bit binary number, and what is the number value? Isn't it? Suppose 8-bit hexadecimal number, okay, and the value is 1. So how can you define it? The value is A1. Isn't it? The hexadecimal value is A1. It is the 8-bit number. So how can you define? A is represented by the 1010, 1 is represented by the 001. Isn't it? Now this is the octal number and it is the 6. The 6-bit octal number 71. So 7 will be represented by the 3-bit, 1 will be represented by the 3-bit, and the number is represented here. Isn't it? So this is basically way to represent the number. Is it clear to all of you? So this is the way that you can represent the digital formation. Just look at it. Okay. Now we have this some curiosity. Say one thing is that Verilog is not defining only 0 and 1 value. It also defines two more value. One is the X and one is the Z. Okay. X means don't care and Z means high impedance. Isn't it? Okay. So you just can I define it? So you can define in the Verilog language by using the inserting the Z keyword. Are you getting my point? So here you can say 8-bit number and it is the binary form. And so what it is representing binary, either it is the 0 or 1 value, you just say that. So here it is representing the, so what is the interpretation in terms of this, what is the interpretation of this number? Here, this symbol will be considered as a Z, high impedance. Isn't it? That is basically represented. So represent the unknown and don't care value and Z, this symbol is representing the high impedance. Isn't it? So when we have the size smaller than the value than the left, most which we will consider. Okay, means we just say that see we want the hexadecimal number and this is 6. How can we represent it? 8 is represented by the 1000 and this 8 will be represented by the hexadecimal 1000. So we will consider the number from here. This number, the 01 is missing. So if you are not writing proper way, it will not consider. Isn't it? All of you getting my point? So suppose this is the 6-bit hexadecimal number, but it cannot be represented by the 6-bit. So what happened? Size is smaller than the value leftmost bit from the value was truncated. So it is truncated. 10 value is truncated. You getting it? Actually, the value is 1000, but due to the truncation, 10 has been eliminated. Isn't it? Because we didn't write in a proper way. Isn't it? Okay. Suppose 8-bit, we have defined a large number of bits for this thing. Binary here, 1 1 है. So how can you represent by the 1 1 only? Then we have the 6-bit extra 6 bit. So these 6 bit can be represented by the only 0 value. Isn't it? Now suppose we have the 8-bit Z1. So we will consider the 8-bit binary number and this is the value of 1 and remaining value are 0. So this is just for your, you can say if you are just making any programming or you want to check what is the input, what will be the output, you are changing the number. So it is just for your information that Verilog, what Verilog can accept. Okay. Now this is the 8-bit binary number. Yes, you can also use this space. So suppose sometimes you want writing a number. maybe the 32-bit number or 48-bit number. So simultaneously it will be difficult to remember that at which position we are working. So we can use this. You can say underscore that we can use it space that how can say underscore two between the two you can say bits the 1010 and it will be considered as a it is considered as a without underscore, isn't it? So this is also the facility available in the Verilog interface. Okay, the negative number basically is represented by the you can say 2-bit binary. You can say 2's complement. Okay, so if you see what is the value of the 6, so if you calculate the value of the what is the is 110. Okay, so if you say if you write first one's complement, invert it, and then add one value. I suppose all of you know that thing, isn't it? So this is the internal representation of value of language. Okay. Now you just see that what is the real number here. So basically we can represent the real number as well as you can say exponent number we can write it. Okay. So sometimes if it is required we can also write the real number. Okay. String is a sequence of characters enclosed by the double quotas. Okay. So we will discuss this. Suppose hello example. So basically it should be here. Hello and keyword is this. That it should be there. Or you can say this. So we can use the string as you have used in the C language, isn't it? So it is a okay. So what is happening here? There are the basically now we want to make the connection. So there are two possibilities. One is the connect by using the wire or using the variable. Variable is nothing but it is the storing element. So generally, what we have in our mind that suppose we are in the register. Okay, register cannot always be treated as a flip flop. I want to just hear one thing. A register cannot be always treated as a memory element. It is not always true. What I am saying that suppose there are the wire W1, W2. Okay. So we have your connection. We can use the wire to connect the two blocks, isn't it? Now I am using the register value to store the data. The register is used to storing the data, isn't it? Okay, so what happened? It depends after the synthesizing the compiler or you can say the our well-known language after synthesizing will assign the register or you can say will assign the register as a flip-flop or as a LUT. It is depending by the you can say after synthesizing during synthesizing. Okay, you can just say that it is the storing element. You cannot say it is the memory element or it is a flip flop. This is the some misconcept come. Okay, so register is to define the variable. Will it be synthesized to flip flop or latch or combination circuit? It is based on the register using the Verilog tool. Cannot always synthesizing in flip flop. So basically, the thing is it you cannot say it will always be flip flop. Are you getting my point? So suppose you are writing the register here, so you cannot say that by using the register you are increasing the memory, isn't it? It will depend upon your synthesizable code. After synthesizing, what is coming out? Okay. So here it is this some more example. Like uh, generally max and variables are the one bit scalar by default value. We can assign the one bit by using the wire, or you can say registers. They will be one bit, but they can define by the vector as well. Suppose I want to connect the buses. Okay, I want to make the communication. Then, while using the wire 32 bit 0 to 31, we can define here wire, isn't it? Now, by using the register of 8 bit, we can say we can define here, isn't it? Okay. And if I want to add the particular value of the data bus, so suppose I want, so suppose this is the data bus of 32 bit, and I want to access the fourth element. Okay, then I can just mention here data bus at, you can say, fourth, isn't it? So the fourth data bus value will be, you can say, zero value will be assigned, and we put this element, you can say 0, 1, 2, 3, 4. So the value is the assign is 0. 1 bit 0 value. I want to assign the address bus 8 bit, it is it. I want to assign 0 to 3, you can say 4 bit. I want to assign like 1, 0, 0, 1. So it is not necessary to define the whole, you can say whole buses or whole length, isn't it? You can work on the intermediate. Okay. So this is the register, and it is the 16 bit, isn't it? And this is the wire matrix. So matrix can be defined by using the register as well as, you can say, using the wire, isn't it? Yes. So, because this is some basic terminology, I will upload these slides, you can say, by today itself, so you can get the idea before coming the tomorrow session at 2 o'clock. Because tomorrow session will assume that you understanding this. So you can go through that, some idea about it. Okay, little bit. Okay. Now the thing is that when we are making a some Verilog coding or we are defining the block, so it is not always necessary you can define everything in a single block. Okay. What you define, divide your work into small parts. Okay. So the same thing is there. Suppose this is the top module which have the some functionality. Okay. Suppose this is the one mid functionality and this is the, you can say, so you can say module top, as I am saying that module is the predefined word, but top is the name of that identifier, isn't it? So I am using mid one another module mid, and that is the inside that top module, isn't it? So we can call them by using the word mid, and then again I am defining one another identifier, isn't it? M1. Same thing is happening here. Inside the top, you can see there are the two modules. One is the mid and another is the bottom underscore 2. So I am defining bottom underscore 2, and this is the B2 and module. And inside that mid, we have another module, bottom. Isn't it bottom underscore 1, and it is the B1. So what is the meaning here? Suppose you have the half adder. You want to implement the full adder. So by using this approach, you can call them. You can call the half adder here itself. So mid M1, you can say half adder, and then you can write any name, isn't it? And here, if you want the another circuit, then you can call them, or otherwise you can make the connection, isn't it? Okay. If you require, I will also upload the Paneskar is the one of the book, Verilog language book. I will upload it. You can, you can say, although it is the, you can say, the book which is available in the not free, but we have the some soft copy, so you can get it. Okay. You can search Paneskar is the well defined for, is the very good book for basic reference, for basic. Okay. So the thing is that here that we can define the different, we can divide our task into the subtask and we can call that subtask in the top task. Suppose top module. Top is the one module, middle is the another module, bottom underscore two is the another module. I am calling bottom underscore one again inside that middle. So you can divide your task. Now to communicate between these block or you can say module, you require the port. You can say input port, output port, or in output. So Verilog support input, output as well as the in output. So in out means it can be treated as an input as well as the output, isn't it? Okay. Okay. So port can be declared with keyword input, output, or in out can be scalar or vector similar to net and variables, isn't it? Now let us discuss about the connection for instance. So suppose I have the top module and inside that top module we have the two different modules. Isn't it? So there are two ways to make the connection. One is called the explicit connection, one is called you can say implicit connection, one is called the explicit connection. Implicit connection means by order. By order means suppose I have the you can say module and it is the you just say that mid. I am defining the name of module mid and I am defining the D in clock and D out. I am defining what is the input and what is the output. Okay. So this is the end of the module and then because I want to use this mid. Okay. Then another module of the top. So I am defining top. And now, what is happening here? When we are calling this mid, isn't it? We are saying that what is the module available here? Clock, D in and D out. So C will assign to clock. P underscore is assigned to D underscore in. Okay, P underscore out is assigned to D underscore out, isn't it? So first I am defining the module top and this is the middle. Okay. So what is the problem here? So both are the way possible, but what may be the possible problem? Say suppose when you are going to the debug, okay, sometime it may be affect when there are a lot of number of pins, maybe one port is missing here. Suppose हमने by default or by mistake I didn't. Suppose there are 32 input output port. Okay, so there will be 32 number 32 identifier here will be for the input output, isn't it? Now, suppose one identifier I have missed, then what will happen? It will consider it will give you some wrong output, isn't it? All of you get my point. And you cannot debug it, isn't it? So that I have to use this explicit connection. So this is the by name, by order. You can say we are assigning the order. So order means it will automatically assigning the you can say clock to C, D underscore to P underscore in, D underscore out to P underscore out. But sometimes it will be you can say during debugging it may create the problem. So what happened? This is the one another connection. It will be good when you have the very small input. Okay, maybe you can debug it easily. Okay. But we have the large number of the input output port, then definitely you should use some explicit connection. Okay. Explicit connection told us that when you are defining the mid clock, you should write that dot clock and then you assign the C there in bracket. You assign the dot D underscore in, you can say, by using the P underscore. So here the order is not important. Important is you are using this keyword clock D underscore in and D underscore out and whatever the connection you want to make by using it C, you want to assign the clock into C, you write here C in the bracket. So this is called the explicit connection. So here order is not important, but it is more easy for a, you can say, language developer. You can say when coding developer. Okay. So generally coding developer or you can say coding coder, we want to use this explicit connection, isn't it? Then this is the parameterized module. What is this meaning? Say you can define a some constant value which may vary according to your requirement in the program. Suppose uh, when we make the generic or you can say very generic programming, we don't define by using the simple constant value directly. We define some parameter. Suppose I want to use the width. Suppose I want to use the value of the 4. But in the next program, or you can say the another program, this value may be changed to 5. This value may be changed to 12. So what I will do, I will define, I will not assign the 4 value directly into the program. Suppose I want to use this output, right? Output of 4 bit, or you can say whatever this 4 minus 1. So 0, 4, I want to make it 4 bit. Are you getting my point? So 4 bit you can directly write here 3 and 0 value. But what happening here? It will be good approach if you define the parameter, okay, and then use it. So it will give you some generic idea. The another person can understand your coding also. Okay. So this is the register, and here you can say you can define this vector quantity whatever you are saying. So this is the output is 4 bit here. Register is you can say 10 bit. Isn't it 0 to 10? Oh, sorry. We have to minus 1 0 to 4. 0 to 4. So it is the 0 to 3 bit. 0 to we have to minus 4 3, but it is the 0 to 3. So it is the 4 bit. So you just say that. Okay. Now inside that you can say I am using this counter. Now this is the you can say input output code whatever you can say just input and output. We are calling them inside the top, and when we are calling them we want to change this value, isn't it? So we can directly use this counter and then we can use this in the bracket fifth value, so it will automatically will change fifth value 4 to 16. Okay, so this is the flexibility is given by the Verilog language, isn't it? So here you can see, uh, okay, so the can be overridden during you can say instantiation by providing the non-defined value within the you can say this bracket. Second, if you are not defining the value, then default value will be considered as a 4 value. Okay. Even though you are not, it is not required to write this best value. You can directly assign 128 value into the counter, it will understand the value, isn't it? But you need to write hash here, and then bracket you need to use, then you need to mention it, isn't it? Is it proper? No, width is the some parameter. Width may be the any value. You can assign it, you can write any name. What is width? Width is in terms of the it is the, you can say 4 bit. Output is the 4 bit of the counter. काउंटर आपने मतलब हमारा 4 बिट का काउंटर है you getting my point so this is the counter 128 counter 128 counter 128 bit 128 bit हाँ isn't it so now we are defining some built-in gates available in the Verilog language. One is the, you can say module. I am defining the module, and suppose input are A, B, enable. outputs are y1 and y2. Okay, so we are input output are the predefined identifier and are the predefined keyword. So now we are giving the name, suppose A1 and A2. Okay, now so we already know that this and is the predefined and it has the one output and two input. So first output it will consider and it will automatically consider remaining to the area input, isn't it? So this is the sum you can say and or nor NAND etc. gates are considered. It is the built-in gate you can call them. Okay. So now this operator. So yes, you know. Okay. So here you can see the arithmetic operator, logical operator, which is available in the C language, can also be used here, isn't it? Okay. So suppose logical operators are there, and then you can see bitwise operator are there, isn't it? And shift operators are there. The materials will be provided to you. These slides will be provided to you. So you just see that how we can use it here. A and B, and we are performing the NOT. So what is it basically? NAND gate, है ना NAND gate, isn't it? And this is the P is less than Q. Suppose here OR gate and then AND gate. So without writing it here, you can also use this. And when you are using this, then you need to assign also. So we are going to assign in the next slides. Say one bit you can also, if C is true, then assigning the value A, if false, then assigning the value 1 to B. Isn't it? So this is the another way to represent this condition. If C is 1, assigning the value A, if C is you are saying that you want the two conditions, there are the A or B, so you want to switch either A or B, so here you can decide. Okay, so it is already defined into no difficult. Now I will just say, uh, suppose this is the number A is written 1011. Now and A is written. So what is happening? This is the single rate operator. When you are using this reduction operator, what happens? First, this A and this A will be AND gate. One will come and one and zero will come again. 0 will come and 0 and 1 again come and the value will be 0. So you can also use this operator in Verilog language. Okay, suppose you have the 2-bit binary number, 4-bit binary number, and the C value is the 1-bit binary number. So now I want to make the same bit number. So then I can simply write the ABC value, then it will automatically consider the ABC value. Yeah. Isn't it? Okay. So this operator you use to combine this. Basically, it is called the concatenation. Isn't it? So any language, if you want to work on language, say this is the best way to give your digital logic concept into your language development. In tomorrow or maybe I will take the lecture on this Sunday at 11 o'clock. Okay, in that time I will give the idea about what is the basically flow, isn't it? So in that way you will get the more idea. Now another is suppose we have the A 2-bit binary number, B is the 4-bit number, and C is the 1-bit number. Okay. Now I want to use the 4 times. I want to call this number 4 times. So I just write here. Concatenation operation can be performed even by calling them numbers. So if you are saying that 4A, you just see that we are writing this 4 0 0 0 0 0 0 4. Now I am calling the B 1 time, then B is calling the 1 time. Now we are calling the C 2 times, it is 0 0, so it is the 2 times. So we can also arrange, we can write in this, isn't it? Are you getting that point? Now, block of statement. Suppose you want to execute the statement sequentially, then in that condition you will use this begin and end or can join. So basically begin and end execute the operation in sequentially manner. Isn't it? And for and join will execute the statement in parallel manner. Isn't it? So this is the basically facility available in this. Okay. So as the C language, you can also use the conditional operator. Okay, or you can say this can be conditional. Okay. So what is happening here? Uh, okay. So what is happening here? So suppose uh, condition if select line is value 0, then y is equivalent to a as begin and then give the value of y equal to b, isn't it? Okay, so we can also define the case, isn't it? There is the one another possibility inside the case whether case z and x, because you are not saying that the 0 and 1, because Verilog language has the four 0 core value, 0 1 don't care and high impedance. So when we are talking about this case z, then it is considered as a don't care condition. But x will not be considered inside it. But when we are considering the case x, in that x and z both are treated as a don't care. Suppose I want to perform this operation in 8 times, then we can also write here. So it will perform, it will execute, it will repeat 8 times. Okay, isn't it while statement as well as in code? So initial value is I, if I is less than 8, it will go to the begin, execute the operation and then increment the value of the I and again then check I is less than equal to it or not. So this is the for statement is also applicable in the website logic. So the concept is same. Now we are going to the structural procedure. Suppose when we are going to the, you can say, some sequential circuits. Okay. And in that time, I want to initialize the statement. I want to give the some initial value. Isn't it? So how can you use it? So suppose uh, the initial, or you can say initial block execute only once during the program. Okay. What is the meaning it here? Say when we are initializing it initial, then we will use the begin and end word. Begin and end will always be used. Okay. And then clock value we will assign the 0 value. Now we are assigning the counter value 0, isn't it? So initially we have assigned this value. Now if the value is changing, it will not going to change that. Okay. So the initial statement will only execute once during the programming whenever it is written. But always statement will execute repeatedly, isn't it? Suppose this is. So there is no ending statement is there. So what happened in the case? So this is the basically delay. We are providing the 10 nanosecond delay. Yeah, so that's why we are has 10 is written. Now clock value we are changing. So basically what we are generating here, initially you are just given the value of the clock value is 0. Okay, so here you are basically generating the clock. After 10 nanosecond the value is changing. So what is the clock period? 20. 0 रहेगा 10 के लिए, फिर इसके बाद 10 सेकंड के बाद वैल्यू जो है वन हो जाएगी, फिर 10 नैनो सेकेंड के बाद जीरो हो जाएगी, फिर 10 नैनो सेकेंड के बाद, so zero will be available for 10 nanosecond, one will be available for 10 nanosecond, isn't it? So basically this clock will execute until what? Until we are during the simulation setup we need to define the maximum time period in which you want to execute the program, isn't it? So you can say both type of blog are, you can say we can make it, isn't it? So both have some their applications, their use, isn't it? Initial use for initializing, always use for the it will continuously run. Isn't it? Now this is the basically the statement may be used when we are making the sequential circuits. When we are saying the sequential, we are saying memory storage element. So this always statement basically there is a very simple way add the rate and enable. If there is any change in the enable value, either it is going for 0 to 1 or 1 to 0, always block will activate, isn't it? Okay. So always log will active. Okay. So what is happening here? Always at the rate of enable and then begin. So we are assigning the register B value inside register A value, isn't it? Okay. So this is the so whenever there is an enable input activated, it will change the value. Isn't it? So it is the another possible say positive edge and negative edge. One more thing is because there are the four values 0, 1, don't care and high impedance. So we need to understand positive edge, what is the meaning of positive edge. So transition from either 0 or don't care or high impedance to one will be considered as a positive edge. Isn't it? Or you can say 0 to high impedance or don't care will also be considered as a positive edge. Isn't it? Negative edge towards 0. If it is moving from 1, don't care or that will be considered as a 0. Negative edge phase. And also if it is moving from 1 to Z value, high impedance also, then also it will be considered as a negative edge. Isn't it? So this is the negative edge. So you can implement the flip-flop using simply always at the rate of positive. Tomorrow we will discuss the counter example. Okay. So these statements will be used in the counter. Isn't it? So basically the thing is that here in this workshop basically aim to divide your work into different parts. Okay. First, we will discuss small part. First, you clear your small task. Then we can define. We can work on the large module also, isn't it? So first, understand the small task, and if you are further interested, we will provide you some more knowledge as per your expertise or as per your interest, isn't it? So this counter we can define by using the always at the rate of positive edge clock begin and then this. Isn't it? Okay. Now I want say not only positive edge. I want the change in the positive as well as the negative edge. So it is also possible in the Verilog language, either you use the or comma. It will reflect whatever the changing when it is changing the either in a positive way or negative way, the value always block will be executed. Isn't it? Sometimes I want that the any change in the any value, isn't it? For that condition, I will use this star symbol at the rate. Then what is the meaning is, if there is any change either in A or in B or in C or in D or in B, the always block will execute. That's it. Okay. Now, as we have discussed about the initialization, initial block as well as the always block, isn't it? So, so basically, initial block is used in test bench. So suppose when you are writing a Verilog code, then you also write the test bench. Okay, in test bench, it will be used for verification whatever the code you have written. So when you are using the initial block will be used for initializing the value, whatever the value you want to give. Okay. Always block are essential element of the RTL and behavior. Basically, always block will be executed as per the language requirement or you can say programming requirement. Okay. A module can have any number of the initial and always block. And one more thing is there, it is not always necessary that the program will always start from the initial block. It may be the parallel execution, isn't it? Okay. It is not compulsory that initial blocks should execute first. It will be executed as per their position, but it will execute once during a program whenever you are ready. But always program will continuously execute. Okay. Okay. So basically initial and always block provide a mechanism to model concurrency means parallel operation. Okay, so we can perform the parallel operation by using the initial and always. Okay. Okay. Now there is the function and task. Sometimes when we want only one output, we will use the function. When we have the multiple output, we will use the task. Isn't it? Okay. Cannot have delays modeled by the positive age or you can say negative age. Say I have previously example mentioned the 10 nanosecond delay. You cannot give the 10 nanosecond delay in the function, but you can give this in task, isn't it? You can define the multiple input output. Okay. Function will execute only combinational circuit and task will can execute combinational as well as sequential circuit also. Isn't it? Call can another function but cannot call another task. Okay. So you can call function another function inside the call. You can say but task can call task as well as the function. Isn't it? Okay, so I suppose this is some very basic definition here. So this is the example of it. So you just see here, in my perspective, you just see that here. Because tomorrow you need to understand what is it is. Please remember that you will find the module is written in your program. You will find that there is one entity name is there by using the identifier. There will be some input and output port. You define the input and output port and perform the operation as per your requirement. You may use the wire, you may use the register if it is required. Suppose in this case I am making a one function which is returning some value. Okay, here out one it will return only the you can say one value. But here task only one value. My function is getting one value. But tasks are getting the two values. So obviously when we are saying my task and this basically you can say one is the input output and you can say sum and query. Okay. So you can say we can perform like this, isn't it? Suppose you want to make the half adder, full adder, then we will define the task. Assignment. So one more thing is there. There is the continuous assignment as the procedural assignment. Okay. Procedural assignment used in the sequential circuit. Okay. Or it will always follow the initial, or you can say begin and end statement, isn't it? I either initial or you can say always belong. Okay. Okay. And you can say continuous assignment. You can say you are just using assigning. Say as I told you previously. Say there is no need to write and or not. You can directly assign the output. So for assigning here, you can directly assign the output. S is true, it is A. If S is equal to false or you can say 0, then assign the B value at the output. Isn't it? So this you can do assign statement, but procedure assignment statement always you can say assignment you always keep the sequential circuit. So always you can say initial block, always block, function and task. Okay. So you can say here always at the rate of positive age. So when there is a positive age, there will be some always statement will execute. Okay. And it will execute always means it will execute continuously, isn't it? Okay, so always at the rate of positive age begin Q and you can, is there any doubt? So there are the two ways to assign it. One is this symbol here equivalent and there is one another symbol. So these are symbol basically called the blocking statement and non-blocking statement. Both will assign the value b equal to q. B value will assign to the Q, but there is the two way. One is called the blocking and another is called the non-blocking. So what is the meaning of the blocking statement? Blocking statement will execute sequentially. So suppose I am assigning the A equal to this has been basically producing the delay. Okay, so the one value three and after 30 nanosecond the one value is assigned to B value. Okay, so it will take 40 nanoseconds. And after executing this 20 nanosecond, after 20 nanosecond, we are again assigning the one value to the C. Isn't it? So it is taking me 60 nanoseconds. But when we are using the non-blocking statement, we are giving the value of the 1 at 10 nanosecond. We are giving the value of the 1 at 30 nanosecond. So what is it? It will execute parallelly. It is executing sequentially, isn't it? So these are the some basic definition you can use to make any program in Verilog language. You just see in this small class I have covered the sequential circuit requirement, combinational circuit, as well as how can you make it. So now it is up to your logic develop capability that how can you use it, isn't it? So we have given you some basic idea. Okay, the slides will be shared you shortly, or you can say in today itself, and you can get some basic idea of this Verilog language. So this Verilog language basically we will use for layout. Suppose you are making some, because you can say in the Verilog language you can make any structure, any system. Now I want to make the, you can say, layout of that system. So in this workshop, the aim is, this is the language is the, I suppose all of you are getting that point. What is the idea behind this workshop? Okay. So I suppose what happening by today itself, there is a very big fault in the electric. Even the our maintenance team was there and the system was off condition, but there is a lot of मतलब system हो गया धुआं हो गया system, or even in the off condition also, or very high spikes is coming in the morning time. So many systems is we have arranged the lab. So you can see here, maybe some systems are working there. So we are working to again develop because we have developed the lab. The whole staff is working day and night and preparing the system for all of you. But in sudden there is a sudden spikes. Even though systems were in off condition, and the staff were in the presence of the staff AMC. We have the some manual maintenance team also, but during in that team also we find that there is some sparking. So you can work in just first floor in the C115. So you can go there, and if the system is working, then our student will help you. How can you make this coding even in the cadence itself? Isn't it? So you can make this programming in the cadence itself also. Okay. Okay. So thank you everyone, and we will meet tomorrow. We have this session, and you can say um, at 11 o'clock by Dr. You can say Anil Rajput. He is working in the company, and he will give the idea about your how can you use the open source tool as well as the you can say you can call them and how can you do the library, whatever free library, how can you download it. So whatever the doubt, first you should have the doubt. If you have the doubt, then we can feed it. Isn't it? So tomorrow we will again meet you and just go and we check. Let us check. Okay.